Okay, here we go. So let's find the Maclaurin series for this. So f of x, and I'm going to rewrite it as to the negative 1 power right away. So finding the first derivative, I have, whoops, I meant to write the negative there. So bring the negative down, 1 minus x to the negative 2, then multiply by the derivative of the inside. So fix it right now. Make this 1 minus x to the negative 2. Get rid of the two negative signs. So then the second derivative will be, bring the negative 2 down, 1 minus x to the negative 3, multiply by the derivative of the inside, fix it now, so the two negative signs go away. Then the third derivative will be a negative 3 times a 2, 1 minus x to the negative 4, times a negative 1 from the derivative of the inside, fix it now, so it's just a 3 times a 2. One more. So I have a negative 4 times the 3 times the 2 times a negative 1. So then it's just 4 times 3 times 2, 1 minus x to the negative 5. So now, since it's Maclaurin, I'm plugging in 0. So I get 1. F prime of 0 is also a 1. Double prime of 0 is 2. Triple prime of 0 is 3 times 2, and fourth derivative of 0 is 4 times 3 times 2. All right, so let's put these together. So 1 plus x over 1 factorial plus 2x squared over 2 factorial plus 3 times 2 x cubed over 3 factorial plus 4 times 3 times 2 x to the 4th over 4 factorial. And it keeps going. This one is one I definitely want to fix up because look at what I've got going on here. The 2's and the 2 factorial goes away. Look at that. The 3 and the 3 factorial, the 3 times the 2 and the 3 factorial go away. The 4 times 3 times 2 and the 4 factorial go away, so I'm left with something really simple to find the summation of, right? So if I want to plug in n equals 0, 1, 2, 3, it's all positive. It looks like it's just going to be x to the n. That's nice. All right, so this one's going to incorporate a little more chain rule. So let's go take a derivative. So I'll get a negative sine of 2x times a 2, right? So I'm just going to rewrite this with the 2 in the front. And I'm going to ready to be taking the second derivative. So carry the negative 2, take the derivative of this. I'll get cosine of 2x times a 2. So I'll get negative 2 squared cosine of 2x. Don't multiply it out, remember. Third derivative, carry along the negative 2 squared. Derivative gives me negative sine of 2x times another 2. So it's turning into a positive 2 cubed sine of 2x. One more. So carry along the 2 cubed. Take the derivative of sine. I get cosine of 2x times a 2. So 2 to the 4th cosine of 2x. All right, let's put it together with their evaluated at the pi. So cosine of 2 pi, you know, is 1. F prime of pi, that's sine of 2 pi, that's 0. F double prime of pi, so that's going to give me cosine of 2 pi, which is 1, so that gives me negative 2 squared. Sine of 2 pi gives me a 0 again. And putting pi in here, I get 2 to the 4th power. All right, so putting it together, I have 1 plus 0, x minus pi to the 1 power, plus a negative 2 squared, x minus pi squared over 2 factorial, 0, x minus pi cubed over 3 factorial, 2 to the 4th, x minus pi to the 4th power over 4 factorial. Okay, let's eliminate these 0 terms. So I have 1 minus 2 squared And then 0's gone. And then 2 to the 4th, x minus pi to the 4th power over 4 factorial. All right, let's do it. So I want this to be the 0, this to be 1, this to be 2. So kind of looking at it, it looks like I've got even terms. So remember, you want to use n equal, or 2n to generate the even terms. So it looks like 2n factorial. Be careful, you have to put the parentheses around that. Because if you wrote 2n factorial, that means 2 times take the n factorial, and that's not what I mean here. I need the 2n in parentheses factorial. This is going to give me x minus pi to the 2n power, and then I've got this number 2 that's to the 2n power, and then I've got that alternating sign again. So let's try -1 to the n. Does it work? Plug in 0, I get positive. Plug in 1, it's negative. That works. There we are.